Here's a puzzle about shapes. How many sides are in the shape formed by placing together a triangle, a regular pentagon, a regular hexagon, regular 7-gon, 8-gon, and so on, all the way to a 65-gon, where every side has length 1. Be careful when you look at questions. Always read them very carefully. This is a question, an example of a question, where it's not that hard to know how to solve, but it's very, very easy to make a mistake. If you read very closely, and if you look at the picture, you will see that there's something missing. There's no square. So the sides go from 3 to 5, 6, 7, all the way to 65. Okay, that's a very important note when you look at any problem. But now that we know that, how would we try to solve to find out how many sides there are? I want to talk about 2 different ways of looking at this. The first way is one where you think about what would it be like if I had all of these not sharing a side and reducing, subtracting by how much extra counting I have. What do I mean? What I mean is that the shapes are 3, 5, 6, 7, 8, all the way to 65. If I could add all of those together, that'll give me a number. And what this number will give me is it will count too much. It will not be the number of sides on the outside, because every side on the inside is actually going to be counted twice, once by one of the shapes and once by the other shape. And so what I then want to do is I want to take this answer and I will want to minus the number of extra. How many extra? Well, you see I said there's 2 times. So extra is always going to mean 2 times the number of these lines that are shared. So it will be 2 times the number of these shared lines. How would we figure that out? That's a question where you want to know how many shapes there were before. You see, here's a picture. I drew 4 of the shapes, and there are 3 shared lines. Look at how carefully I'm explaining this. Whenever you're doing these questions, you don't want to make a mistake of off by 1. So you think very carefully what each number means. If there are 4 shapes, 3 shared lines. So then that means I need to know how many shapes there are in the whole thing, from the 3 sides to the 65 sides. So I will want to know how many are here. How many are here? The easiest way maybe to do this is to say it's 3, 5, 6 up to 65. Why not just pretend it's 4, 5, 6 up to 65? So what I'll say here is that the number of shapes is equal to the number of numbers in the range 4 to 65. How do you know how many there are? You take 65 minus 4 plus 1. This problem is all about the plus 1 and minus 1 at the end. So the plus 1 is because you need to make sure to count the endpoints. 65 minus 4 only counts gaps between numbers. And if I want to know how many numbers, I need to add 1 more back. So if I take 65 minus 4, and then plus 1, this gives me 62. So now I know there are 62 shapes. So I know that the number of shared lines is 1 less than the number of shapes. So this is 61. 2 times 61 is 122. And so that leaves me with just the problem of adding up the numbers 3, 5, 6, 7, 8 up to 65. The same idea as before is actually quite good here. If I want to know 3 plus 5 plus 6 all the way down, it's almost 4 plus 5 plus 6 to 65. Just remember to minus 1 at the end. So let's do that. 4 plus 5 plus 6 plus 65. And don't forget to minus 1 at the end. This is a very standard, there's a very standard way to do these kinds of problems. When you add up a big list like this list of numbers has the same sum as writing it backwards. And once you see that, when you write it backwards, you see that 4 plus 65 is 69, 69, 69, all 69s. And this is a very quick way of remembering the formula, that if I want to add this together, the answer of this bracket is just 4 plus 65 divided by 2 multiplied by how many of them there are. You see, because this 4 plus 65 is each of those, how many are there? Let's remember, we know there are 62. That was from before. There were 62 of the numbers. And the divide by 2 is because if I was to add all this way, I have double counted the whole thing. Okay, so now I need to calculate this out. This thing gives me here 69 times 31. Don't forget the minus 1 at the end. All right, we are almost done with this rather laborious and troublesome calculation. But let's do it. 69 times 31. All right, 69. 3, 9 is 27. 3, 6, 18, 207, 9, 13, 2139. Don't forget the minus 1, and we find that the whole thing here comes to 2138. Okay, and now to finish, I take 2138 minus this 122, and the answer is 2016, which is a very recent year. Actually, this is another tip. Whenever you're doing any math problems, make sure you know all of the properties of the year that you're in and the years that are nearby. So the answer is 2016. 2016, I put here on purpose. It's a very beautiful and very special number. We'll end up seeing a property of it when we do this same problem a different way. You just saw a very complicated way of doing this. Very complicated because the idea was easy, but to do it all carefully was hard. And if you do this, it's very easy to make a minus 1 mistake. Here's another way to do it, where the way of thinking of the method is hard, but the way of finishing from there is easy. How would I make this picture? I could make this picture by starting with a triangle. So what if instead I just thought about this? If I start with a triangle, how many sides does it have? 3. Now what happens if I have a triangle and I add a pentagon? How many sides do I have? Well, think of what I said. I add a pentagon. So it'll be 3, but then how much have I added? Actually, I have added 3 more, and here's how to think of adding the 3 more. Think of it like this. This side just moved over to here. It just moved. And so I added 3 more. Okay? But once you think about it this way, let's see what happens if I add a hexagon. 5, and then here's the 6. 6, okay. So it was 3 plus 3, but when I added this one, what I just did is that one of the sides just moved over to here, and it looks like what I ended up doing is I added 4 more sides. This is actually a very useful way of doing any such problem when you're counting how many sides something has, if you're always thinking of what happens as I add more and more to the picture. That means if I were to do this all the way down, in the end, if I finish it and I go all the way to adding the 65 gone, look at the pattern. When you add the 5 gone, it's a plus 3. Add the 6 gone, it's a plus 4. So the answer to the entire problem is actually just 3 plus 4 plus 5 plus 6 plus, remember when I add the 6 gone, it's a 4. So when I add the 65 gone, it's a 63. Now this is actually a very nice sum. You remember I was always trying to find a trick to be able to add up a sum more nicely. And this is 3 plus 3 plus 4. Well, the first 3, let's replace it with a 1 plus 2. Aha! My answer to the entire problem is this sum. This is what we call a triangular number. This sum, triangular number, is called a triangular number because it's the number of dots in a triangle which looks like this. these 3 dots aren't those kinds of dots. It's just a dot, dot, dot. But it goes all the way down 63 levels. These are very famous numbers. And so if I just had to add this up, I've just showed you one of the beautiful properties of 2016. It's too bad it's not 2016 anymore. But 2016 here is actually the 63rd triangular number. Once you know this, I mean, actually, once you have this, we can just add this up very quickly. Again, we already know when you add up a sequence of numbers like this, 1 plus 2, 3, 4, up to 63, well, that's just 1 plus 63 divided by 2. Okay, that's what we have here, 1 plus 63 divided by 2. That's the average, multiplied by how many there are, by 63. So this is actually going to be very nice. 64 divided by 2 is 32 times 63. And let's just double check to make sure that this really was 2016. 63, 32, multiply, 2, 3, okay, so that becomes 6. This is 12. 126 is here, 9, 1, 8. And so here's the 6, here's the 11, here is 0, 10, and 2016. So 2016 is the 63rd triangular number. But I'm going to tell you something more also. There's another beautiful fact about 2016, not useful for this question, but I'll just share it because once we have chosen this nice number, let's talk about one more thing about it. Have you ever heard of something called binary? Binary is where I write a number like this. If I write a number like 1011 in binary, what that means is that means that I think of this as different place values, meaning whatever is here is counting ones, whatever here counts twos, these count fours, and these count eights. You are not used to speaking in this language of binary. We like base 10 to say 63. But computers speak the language of binary. And if you program computers, which you probably will someday, you'll also be very familiar with it. But this is just showing what binary means. It means I have 1 8, I have a 2, and I have a 1. So this is just 11. Okay? And the thing I wanted to show about the 2016, which is also a fun fact, is if you're trying to write 2016 in binary, actually it's very nice. The reason it's very nice is because here, let me show you a nice fact about binary. If I write 1111 in base 2, that's just 8 plus 4 plus 2 plus 1, which is 15. Actually, whenever I add up powers of 2, I get the next one, minus 1. Okay, 63 is 1 less than a power of 2. So since 63 is just 1 less than a power of 2, 63 is 1 less than a power of 2. This actually means that 63 in binary is 111111 in base 2. Because what this means is that you're adding up 1, 2, 4, 8, 16, and 32. And now, if my answer to the whole problem, or 2016, was 63 times 32, then actually what happens when you multiply by 2 in binary is the same as what happens when you multiply by 10 in base 10. And so what that actually means is that 2016 in binary is 111111, but it's multiplied by how many 2's? It's multiplied by 32, which is 5 factors of 2. So that's 5 zeros. So that's also 63. That's also 2016 in binary. So this number 2016, which came out of the problem, is actually very special. 63rd triangular number, binary representation with all these ones and all these zeros. It's really a shame that 2016 already passed, because you can make so many interesting math puzzles with it.